Hi dear students, welcome to Gravity Tuition Center, Tirupati. Today, I'll be doing the problems from Class 10, Chapter 6, Triangles. Okay, in this exercise 6.2 we will be doing. See here, this particular exercise will be completely depending on the basic proportionality theorem. We will be doing this based on basic proportionality theorem, or it is also called as what? Thales theorem. Thales theorem. So shortly, basic proportionality theorem, we write this as BPT. Okay. So this theorem, how to apply this theorem? Let us understand. See here. So if I have a triangle A, B, C, and there is a line which intersects two sides of a triangle at two distinct points. Suppose they are D, E, and this line, if this line is which is intersecting the other two lines, is parallel to the third side. If it is parallel to the third side, then this line divides the other two lines in the same ratio, that is AD by dB is equals to AE by AC. So when DE parallel to DE parallel to BC in triangle ABC, ABC. Understood? This is how we need to understand. Okay. Now, see, let us see one more theorem is there, that is also we are going to use, that is the converse of basic proportionality theorem, that is converse of BPT. We shortly write it as converse of BPT. Understand? Converse means reverse. See here, first, if line is parallel to the other line, then these two sides will be in the same ratio with this line, right? Okay. Now, what is this? Converse of BPT will tell is, suppose it is a triangle A, B, C, and there is a line. There is some line which intersects the other two lines at D and D and E. Then what this second theorem, that is converse of basic proportionality theorem, states is, if AD by DB is equals to AE by EC. AE by EC. If these are in the same ratio, if these ratios are in the same proportion, then this DE, line DE is parallel to BC. Then DE parallel to BC in triangle ABC. Understand? See, just here, if it is parallel, then they will be in the same ratio, the basic proportionality theorem. In converse of BPT, if they are in the same ratio, then they will be parallel. This is the only thing we are going to use. Okay. Now, let us look into the first problem, the application of BPT. See here, what is given? DE parallel to BC. DE parallel to BC. So, if DE is parallel to BC, what does it mean? In, see here, triangle ABC. In triangle ABC, DE, this line DE parallel to BC. DE parallel to BC. So this arrow, if I show this arrow, this means it is parallel. Okay, if they are parallel, then what is the BPT, basic proportionality theorem? It is this sides will be what? In the same ratio, that is AD by DB, that is AD by DB is equals to AE by EC. AE by EC. Okay. What is AD? Here it is given how much? 1.5. 1.5. Okay. Then what is DB? It is 3. That is equals to, what is this? AE 1. EC we have to find, right? We have to find EC. We can put X or we can leave it as it is EC also, no problem. So what we will do is, this we will send to this side and this we will send to this side. So it becomes, that implies EC is equals to, when this goes to the other side, this gets reciprocated, right? This becomes 3 by 1.5. 3 by 1.5. Here there is a decimal. So after decimal we have one digit. So we have to multiply and divide it with 10, that is 10. So what will happen to this? 3 tens are 30. 1.5 into 10 is 15. 15 ones are 15 twos are. That implies EC is equals to how much? EC is equals to 2 centimeter. EC is equals to 2 centimeter. See here, this is 1.5. This has become how much? 3. So into 2, 1.5 into 2 becomes 3. So 1 into same multiple, 2 becomes how much? 2. Isn't it or not? So this is how much? 2. So this answer is how much? 2. Yes. This is the required solution. Let us move to the next question. See here, in triangle again ABC, in triangle ABC, what is given? DE parallel to BC. You can write here, if you want you can write here, it is given. So if this is parallel, if this and this are parallel, what does it mean? AD by DB, AD by DB is equals to AE by EC. AE by EC. Okay, this is from by basic proportionality theorem. Basic proportionality theorem by BPT. You are writing this by BPT because this is parallel. This is parallel. So this will be in the same ratio. Okay, AD. What is the value of AD? We need to find AD. Okay, we will find AD. And what is the value of DB? 7.2. AE 1.8 and EC 5.4. Okay, now let us send this to the other side. AD we want, so AD equal to 7.2 into 1.8 by 5.4. Understand? So since there is a decimal point and after decimal one digit is there, for this I have to multiply with 10 by 10, multiply and divide with 10 by 10. Same for this, I have to multiply after decimal, we have one digit, right? So 10 by 10. For this also, after decimal we have one digit, so we will multiply 10 by 10. Why we are doing this? To remove the decimal point. So 7.2 into 10, 72. 1.8 into 10, 18 divided by 5.4 into 10, 54. So this 0 we have used, this 0 we have used, this 0 we have 10 we have used, sorry, this tens we have used. What are the 10s not used? This 10 gets cancelled and 110 is left. So 54 into 10. 18 ones are 18, 3s are 3 ones are 3, 24s. So that is equals to 24 by 10. So 24 by 10, if I divide with 10, what will happen? One digit after we have to put decimal point, 2.4, because there is 1 0. 2.4 centimeter. AD is equals to how much? 2.4 centimeter. This is how we can apply the basic proportionality theorem. Next, see here, E and F. Here, E and F are points on the sides PQ and PR respectively of a triangle PQR PQR. For each of the following cases, state whether EF parallel to QR or not. Whether we have to check whether EF parallel to QR or not. This is what is the question. Okay. See here. So PE is given 3.9, EQ is given 3, PF 3.6, FR 2.4. So what we will do is, see here in triangle, okay, what is that? PQR, triangle PQR. So some C ratios are given. We need to prove EF parallel to QR. This is the converse of BPT. Okay, if this should be parallel means then what? This side should be in the same ratio. They should be in the same ratio. That is PE if PE by EQ equal to PF by FR. PF by FR. If this ratio is equal, if the sides ratios are equal, then what? Then we can say that EF parallel to QR. EF parallel to QR. So this is what we will be checking now. Let us see here. CPE how much? 3.9. 3.9. EQ is 3. That is equals to PF. PF 3.6 divided by FR 2.4. See here, there is a decimal point and after this one digit is there. So we have to multiply and divide with 10. Here 3.6. After point we have one digit. So 10 by 10 for this number. And for this also same 10 by 10. So 3.9 into 10, 39 by 3 into 10. Okay. What we can do? 30. So that is equals to 3.6 into 10, 36 by 2.4 into 10, 24. These two tens we have used. This we have not used and they get cancelled. Okay. Now see here, 12 twos are 12 threes are 3 tens are 3 13s are. So 13 by 10. 13 by 10 is nothing but 1.3. 13 by 10. This 3 by 2 is nothing but 1.5. They are not equal. The ratios are not equal. So is not parallel to EF is not parallel to QR. Therefore, EF not parallel to QR. Understand? This is how we will be doing. So, next the values he has changed. Same question. We have to check whether EF parallel to QR in this triangle PQR, right? In triangle PQR, PE by EQ is equals to PF by FR then only then only EF is parallel to QR, right? So PE value how much? PE 4, EQ or QE same, right? 4.5, PF 8, RF 9. Understand? So there is a decimal point here. So into 10, okay. Here also divide and multiply with 10. So 4 into 10, 40. 4.5 into 10, 45. This is 8 by 9. Let us see 5 table. 5 nines are 5 eights are. So this is 8 by 9. This side and this side is also 8 by 9. The ratios are same. The ratios are same. Therefore, the given what? Line EF is parallel to QR. Therefore, since the ratios are equal, therefore EF is parallel to EF parallel to QR. Understand? This is how we will be doing that. Look here, the next question. See here, PE, same. We have to check EF is parallel to QR, right? Here also. So in triangle PQR, okay, in triangle PQR, we will see here PE by EQ, right? The basic proportionality theorem, PE by EQ equal to the ratios PF by FR, PF by FR. But here we don't know EQ, we don't know FR, we don't know FR. Without knowing that, he has given this value, right? This total value. So this total, okay, minus this, if you do, you get this value, right? This total in this, if you remove this portion, you get this portion, right? So 1.28 minus 0.18, this is 1.1. Similarly, this total from this, if you remove this particular portion, if you remove, you get this portion. So 2.56 minus 0.36, how much? 2.2. Understand? So this is also one way you can do. Or what else we can do is, see here, what else we can do is, so corollary of BPT, what we can do is, see here, so just reciprocate this, reciprocate on both sides. So what will happen? EQ, PE by EQ becomes EQ by PE plus is equals to this also FR by PF. Why? Because why? What we are doing here is, why we are doing reciprocating, because here PE value we know, but we don't know EQ. PF value we know. So whichever the value I know, I am taking it in the denominator. Understand? Here this values I don't know. So what I will do is, I will add 1 to both the sides. Adding 1 on, reciprocate on both sides and add 1 on both sides. Both sides. So what will happen? 1 into EQ plus 1 into PE is PE by PE into 1 is PE. That is equals to 1 into FR plus PF into 1 PF by PF into 1 PF. So EQ plus PE, EQ plus PE, this total how much? This is PQ. This becomes how much? PQ by PE is equals to FR plus PF is equals to how much? Total how much? PR. This is PR by PF. Understand? So this is how we can do. Okay. Now see here, PQ is how much? PQ is 1.28 by PE 0.18, PR 2.56 by PF 0.36. So here after point 2 digits, point after 2 digits, point after 2 digits, point after 2 digits. So we can don't have to multiply because everything is having after point 2 digits in all the 4 cases. So we don't have to multiply with 100 by 100, 100 by 100. So ultimately we will get what? This one 128 by 18. We can directly write. We can just remove that. Okay, and this becomes 256 by 36. See here, 18 ones are 18 twos are 128 ones are 128 twos are 2 ones are 2 ones are 1 by 1 equal to 1 by 1. See, if this ratio is also equal, then also EF will be parallel to QR. This is the corollary of basic proportionality theorem. Means this theorem you can extend it for this also, for the other sides, combinations of different sides. Okay, you can check my video on BPT. Okay, basic proportionality theorem. In that I have written. Okay, you can see that. Okay, now this is, see, the ratios are equal. Now we can say that therefore EF parallel to QR. EF parallel to QR. Understand? Next question. See here, LM parallel to CB. LM parallel to CB. Okay, LM parallel to CB. These two lines are in this triangle, right? What is this? ABC. In triangle, in triangle ABC. In triangle ABC, what is given? LM parallel to CB. This is given, right? Okay. If they are parallel, what is by BPT, by basic proportionality theorem? AM by MB. AM by MB is equals to AL by LC. AL by LC. This is one. This we have written from by the BPT, basic proportionality theorem. Understand? Okay. Next, let us take the other part. See here, what is that? LN parallel to CD. LN parallel to CD. So that case we have to take, in this case we have to take this triangle. Okay. In triangle ACD. Triangle ACD. Okay. LN parallel to CD. This is what is given, right? This is what is given. So by BPT, by basic proportionality theorem, what? AN by ND. AN by ND is equals to AL by LC. AL by LC. This is second by BPT. See, RHS same, right? From 1 and 2, RHS is same. So LHS should be same. Understand? So from 1 and 2, okay, we can say that AM by MB is equals to AN by ND. AN by ND. See here, but what we want, AM AN is there, but here MB ND, but here it is different, right? So what I want? I want AM to be retained. I want AM, and I want AN also. I don't want to change this. But this one MB, MB, and this one ND. But here what it is there? AB. I want total. I want total. Here AD. I want total. Instead of this and this, I want this. Understand? So what I will do in the previous case, what we have done, we reciprocate and add 1 to both the sides. Reciprocate and add 1 on both sides. 1 on both sides. So what is MB? This reciprocate. So this will go up, this will come down. MB by AM plus 1 is equals to ND by AN plus 1. So 1 into MB plus AM into 1, AM by AM into 1, AM. Okay. Next 1 into ND, it is ND plus 1 into AN, AN by AN into 1, AN. Understand? So MB, what it is? So MB plus AM. So this total how much? If you add these two, it becomes AB. This becomes AB by, retain this AM as it is equals to ND plus ND plus AN. Sorry. So ND plus AN, this two, if you add, how much it becomes? AD. This becomes AD. This becomes AD, and AN it is already here. Now again, see, same thing we got, right? But it is in the reciprocate form. So just reciprocate on both sides. Reciprocate on both sides. Reciprocating both sides. So what will happen? So this will go up, AM by this will come down, AB is equals to AN by AD. Understand? This is the required answer. Hence proved. I hope you understood. Okay. Next. Let us go to the next question. Okay. See this question. This side and this side we are trying to prove. Luckily we have this side common. So this common, that's what we have taken. See here, AL by LC on both sides, and the other should be in the same ratio. Understand? This is how we are trying to solve the problems. Next, see here. Here DE parallel to AC. DE. Okay. DE parallel to AC. DE parallel to AC. So in this case, what we have to do? We have to take the total triangle. This total triangle ABC in triangle ABC. What is there? DE parallel to AC. So if two sides are parallel, this and this are parallel. That means BD by DA. BD by DA is equals to BE by EC. BE by EC. Understand? Okay. This is, we are writing this particular equation using what? The basic proportionality theorem by BPT. We are writing this using basic proportionality theorem. Okay. The next part, see here, DF parallel to AE, right? DF parallel to AE. So these two sides are parallel. So let us take this triangle, this, okay, this triangle we will take. Understand? So ABE in triangle ABE, DF parallel to AE, DF parallel to AE. So DF parallel to AE means BD by DA, BD by DA is equals to DF by FE, DF by FE. So this is number 2. This also we have written because DF parallel to AE. So by BPT only. Okay. This is also by BPT. Understand? Now, since from 1 and 2, LHS is same. So RHS should be same. RHS should be same. Therefore, BF by FE, okay, should be equal to BE by EC. Okay, from 1 and 2, we are writing this, okay, from 1 and 2. Okay, hence proved. Okay, we have proved it very easily. Understand? This chapter is very easy based on this. This exercise is purely based on basic proportionality theorem and converse of basic proportionality theorem. Okay. Next question, let us see. See here, DE parallel to OQ. DE parallel to OQ. DF parallel to OR. What we need to prove? EF parallel to QR. This we have to prove. See here, if I want to prove this, what I need to prove? This side and this side parallel means what I have to take? This triangle. What I have to take? This triangle. In this triangle, PE by EQ. This ratio should be equal to PF by FR, right? PE by EQ equal to PF by FR. So PE by EQ, okay, PF by FR. So for that, what is there common? This thing. Okay. So first we will take this triangle and then with this triangle. So this will be common in both the triangles. This is common. Okay. And then from that we will get this ratio to be same. So if this ratio is same, then eventually by converse of BPT you will get this to be parallel, this to be parallel. So try to see. So first let us take DE parallel to OQ, DE parallel to OQ. So since these two sides, let us take this triangle. What is this? POQ, triangle POQ. In triangle POQ, DE parallel to OQ, DE parallel to OQ. This is given already, right? If this is the case, if this is given, then PE by EQ, PE by EQ equal to PD by DO, PD by DO. This is by BPT, right? By BPT. Okay. Next, Next, what is the next thing? Here DF parallel to OR. DF parallel to OR. For these two lines, let us take this triangle. Triangle POR. In triangle POR, DF parallel to OR. DF parallel to OR. DF parallel to OR. Okay, if these two sides are parallel, then if it is like that, then PD by DO, okay, should be equal to PF by FR. Should be equal to PF by FR. PF by FR. Let us write this as equation 2. This is also by BPT, right? This is parallel, so they should be in the same ratio by BPT. Okay. Now from 1 and 2, RHS is same, right? PD by DO, PD by DO. So LHS should be same, right? So therefore, from 1 and 2, what? PE by EQ equal to PF by FR. PE by EQ equal to PF by FR. PE by EQ equal to PF by FR. Okay. Now see here. Now we will see this one. See here. PE. This EQ. This PE by EQ. PF by FR. So these are proportionate, which means these points are two distinct points on two different sides. Therefore, what should be the possibility? That is, this EF is parallel to QR. EF is parallel to QR. EF is parallel to QR. This is by converse of basic proportionality theorem, because since two sides, okay, these are proportionate, the ratios are proportionate, therefore EF is parallel to QR. EF is parallel to QR. Understand? This is regarding this theorem, this particular problem. Understand? So first we did this triangle, then this part of the triangle, then eventually when we look into that 1 and 2 equations, we got this PE by EQ equal to PF by FR, which eventually brought us to this, okay, EF parallel to QR. Okay, hence proved. Okay, let us see the next question. See here, ABC are the points on OP, OQ and OR. AB is on, A is on OP, B is on OQ, C is on OR. Okay, such that AB parallel to PQ. AB parallel to PQ. This is parallel. Next, AC parallel to PR. This is parallel. We have to prove that BC parallel to QR. Same way as the previous question, we can do the same way this one also. Let us see how we will be doing step by step. Now AB parallel to PQ, right? AB parallel to PQ. So for this, let us take this triangle. Triangle OPQ. In triangle OPQ, AB parallel to PQ. AB parallel to PQ. Okay. That is, then by BPT we can say that OA by AP, OA by AP is equals to OB by BQ, OB by BQ. This is equation 1 by basic proportionality theorem. Okay. Next, what is the next thing? Next part of the question is, so AC parallel to PR, AC parallel to PR. So this two lines we can get this from this triangle, right? So triangle OPR, triangle in triangle OPR, AC parallel to AC parallel to PR, AC parallel to PR. So if two sides are parallel by BPT, what we can tell? OC by CR, OC by CR is equals to OA by AP. Okay, is equals to OA by AP. Understand? So this is number 2. This is also by BPT, basic proportionality theorem. Since this is parallel, so they should be in the same ratio, right? Okay. If you see this from 1 and 2, from 1 and 2, LHS is same, right? So RHS should be equal. So OB by BQ equal to OC by CR, OC by CR. Now see here, OB, O this by BQ, this OC, this ratio CR. See, OB by BQ, OB by BQ is equals to OC by CR. OC by CR means these points, two distinct points on these sides. Okay. So these ratios are equal, which means BC should be what? Parallel to QR. This is by the converse of basic proportionality theorem. Therefore, BC is parallel to QR. This is by what? Converse of basic proportionality theorem. Converse of basic proportionality theorem. Understand? This B and C are two distinct points which divide OQ and OR in the same ratio. Understand? Now, let us get to the next problem. Using basic proportionality theorem, prove that a line drawn through midpoint of one side, of a triangle parallel to another side, bisects the third side, parallel to one side, bisects the other side. So let us try to understand this question first of all. So the problem is, if you understand the question, then we are almost done. Not half, we are almost done. Okay. See here, midpoint of one side of a triangle. Suppose this is the midpoint, M is the midpoint of this side, of the side AB, M is the midpoint. Then midpoint of one side of a triangle. From here, I will draw a line parallel to this side, parallel to the other side. Okay. Then what he is telling, this particular line which is parallel to the third side, which I have drawn from the midpoint, will bisect, means this also will be what? Equal. This will be also bisects, means it will be in the midpoint only. N will also be the midpoint of AC. Understand? Let us understand this. Let us see this particular See, what is that? M, let M is the midpoint. M is the midpoint of AB. That means M is the midpoint aithe, what does it mean? AM by MB. AM by MB are equal, right? AM equal to MB. AM equal to M midpoint, no. So AM should be equal to MB. Understand? AM equal to MB. Okay. Now, what he is trying to tell? See here, one side of a triangle parallel. See, this is also parallel, right? What is given? This is parallel. So, let us suppose this as 1. We will do small this thing. See, AM equal to MB, right? So, it is given actually. So, let us bring this to the other side. AM by MB equal to 1. This is, let us suppose as equation 1. Now, what is given? Also MN parallel to BC, right? What is given? MN parallel to BC. That implies, by basic proportionality theorem, what does it mean? AM by MB is equals to AN by NC. AM by MB equal to AN by NC. Okay, this is equation 2. Okay, this is in triangle ABC. Okay, see here, and here LHS is same. So RHS should be same. Okay, so from 1 and 2, AN by NC equal to 1. So if you cross multiply, AN equal to NC. AN equal to NC. So what does it mean? AN equal to NC, which means N is the midpoint. See here, prove that the line drawn through the midpoint of a triangle bisects the third side. Yes. Therefore, N is the midpoint of AC. That is, okay, N bisects AC. That is, N bisects AC. N bisects AC. Understood? This is how we do the problem. Okay, let us go to the next question. See here, using converse of basic proportionality theorem. Before we have used basic proportionality theorem, right? So this is parallel, means the ratio should be same, right? So now converse of BPT. If it is in the same ratio, then it should be parallel, right? So we need to prove that it is parallel to the third side. MN is parallel to BC. We need to prove. So using the converse of basic proportionality theorem, prove that the line joining the midpoints. So he is given that this is midpoint and this is midpoint. Okay, this is the midpoint of this side and this is the midpoint of this side. So let M be the what? M be the midpoint of AB. That implies AM equal to MB. Okay, that implies MB, if it comes to this side, AM by MB equal to 1. Okay. Similarly, let N be the what? Midpoint, right? Midpoint of midpoint of n be the midpoint of AC. Okay. Therefore, AN should be equal to what? NC. Okay, let us bring this to the other side. AN by NC equal to 1. Let this be equation 2. From 1 and 2, from 1 and 2, from 1 and 2, RHS is same, right? So, LHS should be same, obviously. So, AM by MB equal to AN by NC, AN by NC. Understood? So, now we got this AM by MB equal to AN by NC. Understand? With these 2 points, 2 distinct points on the 2 sides, these points are dividing these sides in the same ratio, right? So, therefore, the line joining these 2 points should be parallel to the third side, should be parallel to the third side. Therefore, what? MN parallel to BC, MN parallel to BC. So, parallel to the third side. Okay, this is parallel to the third side. Understand? This is how we can prove this particular question. See, previous question and this question same, but using the reverse procedure. Okay, before he gave parallel and we proved this ratio. Now he gave these ratios are proportionate, not directly, indirectly, saying that they are the midpoints. Okay, so from 2 midpoints, if you draw a line, join them, then you get the ratios to be proportionate. Therefore, if the ratios are proportionate, then the sides are parallel. Next, ABCD is a trapezium. ABCD is a trapezium in which AB parallel to AB parallel to AB AB parallel to DC, AB parallel to DC, and its diagonals intersect each other at the point O. They intersect at each other at point O. Show that AO by BO is equals to CO by DO. This is what is the theorem. Okay, now this is quite easy. We can solve this very easily. Let us see. So, this we will take this as he told to take this as O, right? Now, in this, we need to do a small construction in this question. So, AB, what is given here? AB parallel to DC. This is given, right? AB parallel to DC. Now, what I am going to do is, I will draw some construction line. I draw a line OE. I will draw a line OE. This is construction. Okay. So, this particular line OE, how I am drawing is, this is parallel to CD. This is parallel to CD. Draw construction. What I am doing? Small construction I am doing. Draw OE parallel to OE parallel to CD or AB, parallel to CD. Why? Because see here, DC or CD is same, right? DC or CD is same. OE, if OE is parallel to, CD, and we know that CD is parallel to AB. So, OE is also parallel to AB. That is, OE is also parallel to AB. Understand? CD or DC, both are same. Okay, CD or DC, both are same. Both are same. Okay, now draw OE parallel to DC, and we know that DC parallel to AB. DC parallel to AB. So OE will also be parallel to AB. Understand? OE parallel to DC means AB parallel to DC means, so DC is parallel to both. DC is parallel to this and this. What does it mean? AB is also parallel to OE. Okay. Now we have to show that AO by BO, right? So let us do something small thing here. See, now I have taken this side, right? This OE. So let us take this particular side now, DC, right? Now if I take these two sides, the triangle that forms is this. Okay. So what I will take? I will take the triangle ACD in triangle. Proof. In triangle ACD. Here ACD. What is OE parallel to DC, right? OE parallel to DC. So if this parallel, then by BPT AE by ED, I can write like AE by ED, AE by ED is equals to AO by CO. Okay, I can take OC or CO, whatever it is. Okay, AO by OC, or I can take CO also. Okay, I can take CO because length OC or CO both are same. From here to here, same, right? OC or CO, because here CO, DO, AO, BO, I am taking CO. Let us write this as equation 1. This one we are writing by using the basic proportionality theorem. Okay, next, what we are going to do is, see here, see, now OE, right? This one OE, and I will take this AB. I will take AB. So I have to take this particular triangle. This triangle ABD. In triangle ABD, in triangle ABD, OE parallel to AB, OE parallel to AB. That means what? If this is parallel, then this what are proportionate. This sides ratio is proportionate. That is DE by AE, right? Or DE by EA, DE by EA is equals to DO. Instead I will write OD, right? OD by OB. But here you see AE by ED, right? AE by ED, isn't it or not? So here what I will do is, see here, I will just change this to, I will just change this to, instead of DE, what I will do, ED by AE is equals to OD, okay, by OB. Now see here, I will reciprocate. I will reciprocate on both sides. Reciprocate on both sides. So if I reciprocate, this will go on the up, AE, this will come down, AE by ED is equals to OB will go top, OB by OD will come down. Okay. Now See, let us take this as equation 2. Okay, this is by bpt, we are writing this by bpt, right? So equation from 1 and 2, LHS is same, so RHS should be same. That is from 1 and 2, AO by CO is equals to OB by, okay, we need to write here. So what I will do is, here I will interchange this also. See here, OD, right? I will write this as, how I will write, DO by BO, DO by BO, DO by BO, DO by BO. This is DO by DO. Okay. Now here what will happen? What will happen? So this is AO by, see here, AO by CO. This is BO by DO. From 1 and 2 we got this one, right? But look into the answer, AO by BO we want. So bring this to this side and take this to the other side, because CO is on the other side. So rearrange the terms, rearranging. What we will get on rearranging? AO by BO is equals to CO by DO. Hence proved. This is what is required, right? So some problems, trapezium problems, we can use this formula and we can say whether the given quadrilateral is trapezium or not. If the ratios, see this AO by BO and CO by DO, if these are in the ratios, if these ratios are equal, then it can be said as the following is a trapezium. Understand? So this is regarding this question. Simple. Only thing is construction, we have to draw OE parallel to what? DC and AB, and we are using the basic proportionality theorem, and finally we are getting to this. Understand? After rearranging, we will get the required answer. So the 10th question of exercise 6.2 of triangles chapter. See, the diagonals of a quadrilateral ABCD, quadrilateral diagonals ABCD intersect each other at the point O, such that AO by BO, AO by BO equal to CO by DO. So trapezium means it has to be like that. Now, if this sides are proportionate, then show that this is a trapezium. So we know that trapezium, simple condition is that one what? In trapezium, a pair of lines are what? Parallel. So here, if you look here, it is, okay, we need to show that a pair of lines are parallel. Understand? So if I want to show this to be parallel, so same before as before, I will draw one line OE parallel to AB. Parallel to AB. I will draw. Understand? And I am not sure this is AB is parallel to CD or not, I am not sure. But first what I am doing, OE parallel to AB. This is what I know. So this is what I am doing now. Okay. So first thing, construction. So what is given? AO by BO equal to CO by DO. Rearrange the terms. Okay, this will go this side. AO by CO equal to BO by DO. Let us suppose this as 1 on rearranging. On rearranging the terms. Okay. Now what I will do? construction, I will draw OE parallel to AB, parallel to AB. Okay, draw construction. This is given, right? So construction, what is the construction? Draw OE parallel to AB, parallel to AB. Okay, we are drawing OE parallel to AB. Understand? Now, what I am going to do is, I will take this triangle, this particular triangle now. So, ABD, in triangle ABD, okay, we have taken this, right, by construction OE parallel to AB. This is by construction. We have done this, right? So, if OE is parallel to AB, then AE by ED equal to BO by OD, right? So, AE by ED is equals to this BO or OB, right? BO or OB. Okay, we will write BO only. We want BO itself, right? BO by OD or DO. Okay, this is by BPT. This is by BPT. See here, BO by DO, BO by DO. Understand? From 1 and 2, we can see RHS is same. So LHS should be same. LHS should be same, right? So from 1 and 2, from 1 and 2, we can write AE by ED equal to BO by DO, which is also equal to what? AO by CO, right? All together we can combine this way also. Understand? So AE by ED and AO by CO, right? AO by CO. Understand? So AO by CO. This is same. Understand? So from 1 and 2 we can say that these two are equal because RHS is same, LHS should be equal. Now see here, now see the beauty here. See, we have assumed OE parallel to AB. But now see AE by ED is equals to AO by CO. AO by CO means these two distinct points on these two sides. What? These 2 points are making the sides AD and BC. AD and BC, okay, it is dividing these two sides into the same ratio. Same ratio. Therefore, EO is parallel to BC. Therefore, EO is parallel to BC. Therefore, EO parallel to DC. EO is parallel to DC. Understand? This is how we have done. So EO is parallel to DC, and we know that EO is also parallel to AB. Okay. Okay. Also, okay, EO or OE, right? OE parallel to DC. Okay. Also OE parallel to AB. That implies DC and AB are also parallel. AB is parallel to DC. Okay. If in a quadrilateral, if two sides AB and DC are parallel, then we can say that the given quadrilateral is a trapezium. Here, what are the two sides parallel? AB, AB and DC are parallel. So, therefore, the given quadrilateral ABCD, quadrilateral ABCD, quadrilateral ABCD is a trapezium. It is a trapezium. Understand? So this is how we are doing this problem. I hope you understood. Okay, if you don't understand, repeat and observe these videos. Okay, if you want, if you feel it is a bit faster, you can slow down, or if it is slow, you can speed up. Okay, thank you for watching. Thank you so much.